Hey there, I was going through some of my notes and looking at some of my projects here earlier today, and I realized that I probably had enough information to shoot a short video about spindle indexing in Mach 3 and using it on small machines like the Harbor Freight mini lathe and mini mill and whatnot. So thought I would take just a few minutes, put together a really quick video and put all the information together that I wish I would have had when I first started working on the spindle feedback for these things. So here we go. So I'm going to give you not all the information, because there's always someone out there that has more information, but I'll give you what I have, and hopefully it will be helpful. So the first thing to talk about with this stuff is the sensor. So when you read the Mach 3 manual, they'll talk about a couple different types of sensors. They'll talk about optical sensors. They'll talk about ones that break an infrared beam on a disc with perforations in it. They'll talk about sensors that read marks on a shaft. They work pretty good, and that's probably what most people are using. I have been using magnetic sensors for the projects I've worked on, and I've had really good success with them. And I'm not going to say that they're better than optical sensors, but I'll tell you why I like them and why they work for me. So I'm not going to spend a lot of time about how to build sensors or how to affix them to your machine. I have a different video on my YouTube channel where I talk about building a sensor using a Hall effect sensor and a magnet, and that's actually what I have here. I took the sensor that I had on my milling machine, and I took it off of that, and just sort of temporarily rigged it up here on this mini lathe. Come up with something a little better later, but it'll serve the purpose for now. So the reason why, well, let me take a step backwards. So the manual, the Mach 3 manual, gives you some formulas that are pretty important. So when you're designing your sensor apparatus, you have to make sure that the signal is of a long enough duration that Mach 3 can pick it up. So they give you all these little formulas to work on, and I just did some quick stuff here. So I just made an assumption. Let's say, like on these mini lathes, you're probably not going to be running faster than 3,500 RPM. Maybe you are, but I just made that assumption. So if you're running 3,500 RPM, according to the formula for the mini lathe here, or whatever, for a machine of that range, the slot angle, this is sort of based off of a sensor using a visual sensor breaking a beam on a disc. They're saying the slot angle needs to be 4.2 degrees if you're running 3,500 RPM. And then you take that into account along with the diameter of the disc. So here again, this is, you can see what they have set up there. The disc is a pretty good diameter, but I did the math for the mini lathe. So the 0.0088 times 4.2 degrees times 1.6 inches, and I'm getting that from right here. The diameter of the shaft where I have the magnet affixed is about 1.6 inches. So what that tells you, at that diameter you'd need a slot width of about 0.059. Now obviously the larger the diameter of your disc, the larger the slot width needs to be. So those numbers are really designed for these sensors that work with like an optical pickup. I'm using a magnetic pickup, but it's kind of like the same thing. What they're trying to do is give you some formulas that help you get the proper duration for your signal. The signal needs to be long enough, or of a duration that's long enough that so your computer and Mach 3 and everything has time to pick it up. So if you had like a 4-inch diameter shaft and you only had like, let's say a 50 thou wide slot, the signal wouldn't be long enough for the software to work. So that's what they're trying to do. So fortunately, I'm using a 3/16 diameter magnet. So long story short, on this 1.6 diameter shaft, a 3/16 diameter magnet, the duration should be plenty long enough to work with these little magnetic sensors. The other thing I like about these, using a Hall switch, a Hall effect sensor, you can see I made my sensor and I just used electrical tape and taped a magnet to the shaft. I won't stay with that forever, but it's like really quick and easy to try it. It doesn't take much. On another machine, I just drilled a little hole in one of these nuts and I epoxied the magnet inside of it, and that worked really well. I never had a problem with it. If you're doing the optical sensors, not only do you have to come up with your optical sensor and wire it up and do all that, and you also have to make your disc, which probably isn't really a big deal, but you know, it's something else to do. So there you go. So there's the sensor. I'm using a Hall effect sensor, but it really doesn't matter what kind of sensor you use as long as you're generating a signal. I've only ever used one magnet or one trigger on my shaft. Apparently Mach3 will do math. If you have multiple signals wrapped around your shaft, it'll apparently calculate it, but I've only ever used one magnet, or what would be like one slot in your timing disc. As far as the interface, there again, that's up to you. I'm just hooked up into a TB6560, real inexpensive driver, and I'm feeding that right into a parallel port. So nothing too fancy there. One comment I will make, and talk about this more later, if you're using a smooth stepper, the smooth stepper causes a few things to work differently in Mach3 when it comes to the spindle index and the way that works. So I'll talk about that later, but this setup is with a parallel port. So okay, after you do that, so you have your sensor, you have everything wired up. You know, you want to be in the diagnostic mode, so as you want to verify that your sensor works. So as I roll my magnet, you know, I can verify, you know, the index signal is working. So that happens on the diagnostics mode screen. So I kind of skipped a step. Along with working on the diagnostics, you're also going to want to make all your configurations. So the first thing you need to do is go here to config, ports and pins, and first thing you want to do is look at this tab, the port setup and access selection. What's important here is the kernel speed. So I have mine set at this. So if you make changes to these numbers, it's going to change the way that the computer system picks up your index signal. So just keep that in mind. If you're changing that, it's going to affect the way the system reads the signals. So that's all there is to say about that tab. The next thing you need to do is go to your input signals, and down here is the index input. So basically you just need to make sure that this is, you know, checked and enabled, reading the right port, the right pin. And the way I have my sensor wired up, it works best on active low. So that's totally going to be dependent on how you wire up your sensor, what you're doing with that. The next screen that you need to deal with is spindle setup. So there's a few things here to say on the spindle setup screen. So the first thing you need to know is, even though you're not, I'm not controlling my spindle with Mach3. I have manual spindle control. I'm not using Mach3 to turn the spindle on or to control the speed, but you still need to define an output pin for the M3 and the M4 signal. So I'm not using them. but you still need to define it. If you don't put values in there for the output for M3 and M4, none of the spindle indexing stuff will work. The next thing you need to know is speed averaging, spindle speed averaging. I have that turned on according to the documentation that it reads multiple revolutions, then averages the RPM. They say that's good to use for little machines where there's not a where you may get more fluctuation. I guess if you have a big machine with, you know, the spindle's working more like a flywheel, you may not see as much fluctuation. But small machine, they recommend check the box next to spindle speed averaging, and the other box there that's checked, use spindle feedback and sync mode. As far as I can tell, you probably always want to have that checked. I kind of think I know what that does, but I'm not going to talk about that. But my guess is you probably would just want to have that checked all the time. So, all right. So that's everything under spindle setup. The next thing you want to do, get out of this screen, is go to the general config screen. So what you need to know on this screen is right up here, input signal debouncing, noise rejection. And there's actually one value is for all the input signals, and then there's a separate value only for index debounce. So what this does is it tries to set a, I guess, you know, when you contact a mechanical switch, it's not just a simple off or on. Apparently there's like a whole series of like off on, off on, off on that kind of happens, you know, super quick, and I guess they call that the signal bounce. So right here is a filter that debounces the signal. So the switch has to be on for 40 times 40, so you can do the math. 1600, 1600 microseconds before the software considers it to be on. So if it's bouncing and it's not on for 1600 microseconds, it won't call it an on. Depending on how this works, this value might default to 0, it may default to 200. If the number is too high, what you may see happen is your index signal is working good at low RPMs, and then when you get to high RPMs it goes crazy and you no longer get a good number. And that's because the faster the spindle's turning, the shorter and shorter the duration of that pulse is. So I have mine set to 40 or 1600 microseconds. I'm not sure what will work for, you know, every configuration. I have a really slow computer, and so that's something that you'll probably just want to experiment with. So that's the last setting. So now, after you work through all that, here's the next thing you need to know. So, and I've seen people get tripped up by this, so I'm going to turn it on. Notice there is no feedback on the spindle display, nothing. But at this point, everything works. You know, if you go to the diagnostic screen, you're still getting the little lights turning off and on. Everything is working. So this is something. It's like it's so simple. It makes you feel dumb when you figure out what it is. But I struggled with this for a while before I figured out what the problem was. When you turn your spindle on, Mach3 needs something to tell it that the spindle's on. So if you click the spindle button down here, now Mach3 knows the spindle is on. If you don't tell it the spindle's on, it won't know it's on. You can also MDI a spindle command, you know, an M3, and as soon as it sees that command, now it knows the spindle's on. So don't let that trip you up. Just make sure you give Mach3 a command to turn on the spindle. So that's pretty simple. So yeah, once you do all that, your spindle should be working. Mach3 should get some input. So let me just go ahead and hit the spindle button. I'll turn it on. I'll run this thing up to my max RPM so you can see what it does. So for whatever reason, my little Harbor Freight mini lathe here runs a little faster than 2500 RPM, and there are adjustments inside here on that control board that that let you tweak that. I haven't tweaked mine. It just happens to run a little faster than 2500 RPM right from the factory, so that's cool, no problem. So last but not least, so I have a short little program here that I can run that I'll show the difference here between you know, a low spindle RPM and a high spindle RPM. So I have just a dumb little program I wrote. I'm just going to move the z-axis, and G95 puts it in inches per rev instead of inches per minute. So let me rewind this program, and I will turn the spindle on to a low RPM, and I'll just cycle through this, and then I'll run it at a higher RPM. You can see the difference. So this is kind of the end game here, right? You want to have you know, be able to do feed per rev instead of feed per inches all the time. Okay, now we'll turn it up a little bit. So there you go. So that's pretty much it. So I haven't done any threading yet. I hope to do that soon once I get my machine here finished and have some tools on it, but that's kind of the ultimate test for spindle feedback, and I'm feeling good. I think it's going to work out okay. So I hope that was helpful. That's the video that I wished I had available to me when I was starting to play with this. I hope it saves you a little bit of time and helps you get your projects up and running a little bit faster. Thanks a lot.